book does a great job of going over it. Okay, on to 16.9, polyprotic acids. The prefix poly means many, so polyprotic acids means we have many H's to give away. Alright. In this situation, successive ionization means we're peeling off an H at a time. So what we're going to start with is H2SO3. And let's add water to it. You could add water, you wouldn't have to, it doesn't matter. But at one point, you're going to get H3O pluses. And your first ionization is we're just pulling one H off, so we're going to get HSO3 minus. Then down here, the successive one, HSO3 minus plus H2O. One of our products is going to be H3O plus. The other product is going to be SO3 2 minus. Alright, if we look, the second ionization constant is always much smaller than Ka1. Why is that? And up here, if we were writing these out, Ka1 would be this one, Ka2 would be this one. Well, the second one is smaller, much smaller, because this is an equilibrium, which means it's already small. And then we have Le Chatelier's principle taking over, which shifts it back and forth, and it's just a lot of work. All right, so this is going to be really small. If you're ever asked on an AP exam, which of these is the lowest in concentration, you're going to guess this one. All right, that will always be the lowest in concentration. So let's see if we can't solve one of these problems, and we're going to need actually probably most of this slide. So here we go. We're supposed to find the pH of ascorbic acid, a 0.1 molar ascorbic acid solution. We've got Ka, Ka2, and we're also going to find the concentration of C6H6O6 2 minus. So here we go. Our first step is going to be to write our successive ionizations. So let's start with that. So we've got H2C6H6O6. We're going to add water to that. And we're going to get H3O pluses as well as HC6H6O6 minus. And then I'm going to write the other one right over here. Actually, let's write it down here just a little bit. HC6H6O6 minus. We're going to add water to that. Arrow, arrow. We get H3O pluses and C6H6O6. And that one's going to be minus 2 or 2 minus. All right, so let's start filling in our stuff. We know that we're starting here with 0.100. All right, 0, 0, minus x. So this is going to be 0.100 minus x. That's x, that's x. So that's going to be x, that's going to be x. Before we can fill in this bottom part, we kind of have to figure out that first one. So Ka1 is equal to 8.0 times 10 to the negative fifth, and I'm going to just skip the equilibrium constant expression for right now, but we know it's products over reactants, so we're going to have x times x over 0.100 minus x. Lose that little minus x. And times 0.1, and then we're going to take the square root of that. Which should give us x's value, and this first one is going to be 0.002828. So that's our value for x. So let's just slide these values of x down here. 0.002828, that's 0. We're going to start with 0.002828 minus x, so 0.002828 minus x, and this is going to be plus x, 0.002828 plus x, and that's just going to be plus x. Yes, I know I gave us another x, but it'll still work out. So now we're ready to plug it in for the next one. So Ka2 is equal to x times 0.002828 plus x over 0.002828 minus x, and that's going to be equal to 1.60 times 10 to the negative 12th. So hopefully you see something awesome happening here. We get to do a lot of canceling. First off, the little x, right? Now, if you see, boom, these cross out. So our concentration of X, or our concentration of C6H6O6, 2 minus, is going to be equal to 1.60 times 10 to the negative 12, which is the Ka2. That's a step you get to skip if you want to skip right to the end. That won't work for Ka3. You would have to just keep rolling. But for Ka2, it does work. All right. Now, if we add this value up here to our X value, it's not going to make any difference there. So we're just going to leave it out. And we need to find the pH of this number because this is our hydronium ion concentration, right? So we're going to take pH is equal to the negative log of 0.002828, and this will be our pH. And our answer should have come up with 2.55 is our pH. And so that's hitting both of them. And that's it for today. I'm going to let you read 1610 because I think you can do it. All right, see you next time. Bye.